In this tutorial, we're going to take a look at correlation. So let's set up a research question, then we'll open up a data set and we'll take a look at how to analyze a correlation. So let's imagine that we're psychologists studying the concept of grit. Grit has been called a lot of things, but generally it's a tendency to stick with a goal no matter what, or to be able to plan ahead for long-term payoffs. And we want to know, does grit correspond with your persistence on an observed task? So let's imagine this scenario. We have students come into the lab, they complete a scale that measures their grit, self-reported, and they also are then asked to complete a puzzle, and they're told to spend as much time on the puzzle as they feel like they can to be able to solve it. Unknown to them, the puzzle is actually impossible to solve. So really what we're measuring there is persistence. That is the amount of minutes that the student spends on the puzzle before they give up. So imagining this scenario, we have two variables, grit and persistence. If we were to frame this as a null hypothesis, we are starting with the presumption that there's no relationship between grit and persistence. Our alternative hypothesis would be that there is a positive relationship between grit and persistence. So this is what we expect. People who stick to their goals are also more likely to stick with a puzzle even though it's difficult. So we're going to start with this data set, Psych 200, grit and persistence, and I'll click over there now. Okay, so within our database, we have two variables, grit and persistence. I'm clicking into variable view so that I can look at both of these. I've labeled them both so that I remember which direction they go. This can be really important in correlational data. Sometimes a variable might be scaled the opposite way of what is intuitive. So in this case, I remember that the grit index is scaled so that high scores mean more grit and low scores mean less grit. And in the persistence measure, we're measuring the total number of minutes spent on an impossible puzzle. So high scores would represent higher persistence. Both of these are scale variables, also known as continuous variables, also known as interval ratio data. So with that, it makes it a perfect fit for correlation. What we're looking at are the relationships between these two variables. So I'm going to analyze, and from analyze, I'm going to go to correlate. And what we're doing is a bivariate correlation, a correlation between two variables, bivariate. Now I'm going to choose both variables and put them into the variable box. The default here is a Pearson correlation, which is what we would choose. A Spearman correlation would be used for something like ordinal data, non-continuous or non-interval ratio data, but we're not going to use that for today. Also, our test of significance is defaulted to a two-tailed test, which is more conservative. So we'll go ahead and stick with that. We're less likely to have a false positive in this case. And then also just a helpful thing is that it automatically will flag a significant correlation with a little star or an asterisk. So let's go ahead and hit OK. Now I notice that my correlation is set up so that it's a bit of a matrix. Since I only have two variables here, there's really only one piece of data to look at. However, often when we're doing a correlation table, we might have 5 or 6 or 7 variables that we want to look at together. So this becomes really useful to look at all the correlations in one spot. So here I see my score on the grit index and my minutes spent on the impossible puzzle. And here's the Pearson correlation. So here I see that the relationship between the score on the grit index and the minutes spent on the impossible puzzle is a relationship of 0.428. Down below, I can see that within that relationship, there's a significance level or a probability value of 0.01. I also see below that my N, which tells me the number of participants, which in this case is 35. So what you'll notice is that the same information is redundantly provided down here. This just allows you to organize the data whichever way is more useful to you, but it's really the same information. So what I can do with this is to see that the significance level or the probability value is below 0.05, meaning that A relationship of this magnitude is not very likely to happen by chance, less than 5% of the time. So that allows us to then reject the null hypothesis that there's no relationship and instead find support for the hypothesis that there is a relationship. What the correlation amount can tell me is how strong is that relationship. So if it was lower than 0.3, for example, we might call it a very weak correlation. Between 0.3 and 0.5 is what we would call a moderate correlation, and then higher than 0.5 would be a strong correlation. So that's kind of like an effect size built into the correlation data. And then finally, we can look at the direction of this relationship to determine if the relationship is working the way that we thought it was. That is, that the more grit a person reports, the more minutes they spend on a puzzle before they give up. And it turns out, because it is positive, that it is indicating that that's the case. So higher scores on grit are also associated with higher scores on amount of time working on a puzzle or persistence.